Adding and subtracting rational expressions is exactly like adding and subtracting any set of fractions that you've ever seen before. If we have a common denominator, then we can add and subtract, right? So the first thing that we have to have is the number on the bottom. The denominator's got to be the same thing. Then we just add and subtract across the top. Now, there's a couple things that come into play. For instance, when we subtract, what happens to the signs of the second polynomial that we have right there? We've got to change all the signs and whatnot. And there's a couple of other steps that will come into play, and I will go over those as we hit them on this particular lesson right here. Okay, so out of the gate, let's go old school. And we got this, 1 over 2 plus 3 over 2. The denominator is the same, so all we do is add the top together. So 1 plus 3 just becomes 4 over 2. Now, the second thing that we have to do is we have to reduce that fraction as well, or simplify. So in this case, 4 divided by 2 just turns out to be 2. So in the end, when we add 1/2 plus 3/2, we end up with the number 2. Second problem we have right here, x plus 4 over x plus 3 over x. The denominator is the same, so all I got to do is add and subtract the top. And here's what it looks like when I do that. Now I'm going to break it down, and I'm not even going to mess with the denominator. I'm just going to rewrite this, x plus 4 plus 3. Now that right there, we can simplify one step further. Why? Because 4 and 3 are like terms, so here's what we have, x plus 7. Now let's bring in the denominator, which is just x. By the way, it does not change, does it? Here we have the 2's. Now, I did not make that 4. The denominator stays the same when we add and subtract. So in the end, I'm left with this, x plus 7 over x. And from the other lessons that we have with multiply and divide, if I want to simplify x plus 7, I got to simplify the whole thing, okay? Not just one or the other. So this x and this x do not cancel out. This is done right here. That is as simplified as that problem can be. Take a look at the third one that we have right here. 2x over x plus 5 plus 10 over x plus 5. Again, plus or minus sign. I'm looking for common denominator. X plus 5, x plus 5, they're the same. So all I have to do is add and subtract the top. So here's what we ought to have. 2x plus 10. Now there's nothing else I can do to that, is there? I don't think so. So go ahead and bring the rest right here. All right. At this point right here, now we go back to 2 or 3 lessons ago when we were just simplifying rational expressions. And the rules are basically this. Factor completely, eliminate the things that are the same. Can we factor this on the top? Well, yeah, the common denominator, or the greatest common factor here is going to be 2. So if I take that out, I'm left with this, 2, and then x plus 5. And on the bottom, I have x plus 5. And recall, if I'm going to eliminate sameness, and there's a plus sign in between a variable and a number, it's all or nothing, right? So here's x plus 5, and there's x plus 5. They both go away. So in the end, on this one, we're left with 2. There's a nice answer. It won't always turn out that way, but again, be grateful when it does. All right, so a couple more. Let's take a look at this. Now we're getting into subtraction. So a couple of things change, but the basic rules don't. So here's what we got. 7 over 4 minus 5 over 4. Adding and subtracting, got to have a common denominator. I do have a common denominator, so all we need to do is this, 7 minus 5. Well, I hope you know 7 minus 5 is 2. So we're left with this, 2 over 4. Can we simplify that fraction? Yeah, we can, right? So we should know that 2 over 4 just breaks down to 1/2. Okay, so there's the easy one. That's just a recall, hey, from elementary school, how to do things. Moving to the second one right here. 7 over 2m minus 3 minus 3m over 2m minus 3. It's a subtraction problem. So again, you're looking for this, common denominator. It exists. There's 2m minus 3 and 2m minus 3. So all we need to worry about now is the numerator. So let's set it up. 7 minus 3m. Okay, because there's no like terms here, there's no work to do anymore, then I'm pretty much done adding and subtracting the numerator. So now all I need to do is bring the denominator down. And again, can't be clear enough on that. The denominator does not change when we add and subtract, okay? Now here, I cannot factor the top at all. I cannot factor the bottom. So there's a completed process right there. That is the subtraction of those two rational expressions. Now, you know on the last one we got to do something different, right? It's a subtraction problem. There's my minus sign in the middle right there. X plus 4, so that means the denominators are the same. So we need to subtract the polynomials that are in the numerator. So here you go. Set it up like this. Guys, I can't tell you enough. I got to suggest write it down. It's too easy to make this mistake in your head. Now there's a minus sign. So what happens to these two numbers right here, right? Their signs have to change. So it becomes minus x plus 15. Okay? That's where you're going to slip right there, and that's where you're going to fumble the ball, so to speak, and you won't get a proper answer when you probably know what you're doing. So here we go. Combine like terms. 5x minus x is 4x, and 1 plus 15 is 16. Okay, so I'm done adding and subtracting the top. Now bring the denominator over. X plus 4. Recall from way over here, when we had 2 over 4, we had to do what now? Now we got to factor completely, and we have to eliminate sameness. We can factor the numerator. Okay, so in this case, there's two numbers. So I need to find the greatest common factor, so it becomes 4. Now we're left with this, x plus 4. Uh-oh. Hopefully some things are starting to light up for you. There's nothing to factor in the denominator, but that is factored completely. Now I am looking for sameness. And here's x plus 4. If I want to get rid of them, get rid of one of them, I got to get rid of both of them. Thank God, x plus 4, x plus 4. Both of those are gone. And now the result of this problem is 4. Okay? So again, add, subtract fractions, looking for common denominator. If it's there, add or subtract the numerators. When I'm done with that, then I factor completely, eliminate sameness, and then go from there.